Now we are seeing a case from the topic impact of jet on winds, and the case is force exerted by jet on an inclined moving plate. So here is a plate, inclined plate, flat plate, but it is inclined, which is moving with the velocity of u, and the jet is coming with velocity of v. And if you see here, consider a jet strikes on an inclined plate moving away from the jet, and here let v is equals to velocity of the jet, u is equals to velocity of the plate, and a is the cross sectional area of the jet, and theta is the angle between the jet and the plate surface, or plate simply you can say. And if you see here, the relative velocity means plate is moving with velocity of u, jet is moving with velocity of v. So relative velocity between jet and plate is v minus u here. And if you see mass flow rate, if you see here, we can write w by g a into v minus u. So we have seen in the initial cases, when the plate is at rest, the mass flow rate will be w by g into a into v only. But here a plate is moving, and so jet is anyway moving. So there is a relative motion or relative velocity between jet and plate. Here the mass flow rate will be W means the mass of fluid or jet which is striking this plate, that is per second, that is mass flow rate if you take. So that will be W by G into A into V minus U. So here let us calculate, take our initial relative velocity of the jet normal to the plate. See, we are calculating, or we are finding in the first step, initial relative velocity of the jet normal to the plate means this normal component. So this is the plate, and this, if you see, this normal component of velocity. So this we are finding out here. Suppose if you assume this is a plate and this is the jet which is striking it with a relative velocity v minus u. So it is striking this inclined plate, and here is the theta is the angle between this jet and plate. So this component is v minus u component, and it is making theta with this plate. So when you resolve that into two components, one will be the along the plate, one is normal to the plate. So we are interested in normal to the plate component velocity. So that will be, so if you see, this is v minus u and this is theta, so this will become, this is a perpendicular component. So we know this will be cos component because it's adjacent to angle. So this component will be v minus u sin theta. So from this diagram you can say the normal component of velocity which is perpendicular to this plate will be v minus u sin theta. So that is nothing but initial relative velocity of the jet normal to the plate. So that is, we are taking it as v1. So that is v minus u sin theta. Next, final relative velocity of the jet normal to the plate, that will be 0. Why? Because here we are writing final relative velocity normal to the plate. So when the jet is striking, after striking, the jet will move the perpendicular to the normal. So the jet will move along the plate. So but we require velocity in this direction. So this is moving like perpendicular to the, or along the plate. So the normal component of relative velocity after our final relative velocity of the jet normal to the plate will be 0. So that is v2 is 0. So here we are writing force exerted by the jet normal to the plate, Fn. So from the basics we can write it any case force exerted by the jet on the plate as m dot into v1 minus v2. So we have taken v1 is initial relative velocity normal to the plate, v2 final relative velocity normal to the plate. So we are calculating here normal force means you can write Fn is m dot into v1 minus v2. So m dot we have seen it is w by g into a into v minus u, and v1 is v minus u into sin theta, v2 is 0. So when you substitute all these values and when you just simplify the next step, Fn, the force exerted by the jet normal to the plate, is we are getting, it is w by g a v minus u into v minus u means v minus u whole square sin theta, and anyway this is 0 means, so the Fn normal force is w by g into a into v minus u whole square sin theta. So this normal force can be resolved into two components, that is along x direction and along the y direction. So this is a normal force. So once again, if you see, if you take this as a y direction, and this is anyway z direction is x direction, and this is a normal. If you see, this is normal, and angle between this y direction or y direction and this normal is theta. So how we can say means, just observe this line diagram. So this inclined is line, we are taking it as, or we are considering it as a plate, and this as a jet we are considering. So angle between the jet and this plate is theta. It is we are given, it is given, or we are taking in the initial steps as theta. And if you see, this line is a vertical line, so angle between this z direction and this will be 90 degrees. So from this diagram you can say this is 90, and this theta is given means, so this angle will become 90 minus theta. So once again you consider this plate and this Fn. So these two are perpendicular, means these two are at 90 degrees. So if this is 90 minus theta, this remaining will be theta. So you can say finally the angle between Fy and Fn is a theta. So that you can write, and you can resolve this Fn into two components, Fx and Fy. So you can write Fx as Fn sin theta. Why? Because this will become sine component and this will become cos component, we know. And so this component is Fx we are taking because it is in the x direction. So Fx means you can write this as Fn sin theta. So we have seen already Fn, we have seen here it is W by G into A into V minus U whole square sin theta. So in the place of Fn you can write this as same, and sin theta is there here. So once again you are writing sin theta. So just simplify when you just do this. So it will be W by G into A into V minus U whole square sin theta into sin theta sin square theta. So this is the force in the x direction, and in the y direction if you see, it is we can write Fn cos theta. This will be cos component, so this is Fn cos theta, that will be Fy. So Fn we have seen the same thing, that is here W by G into A into V minus U whole square sin theta, and here cos theta is there, so cos theta. So the Fy component of our force in y direction, or Fy, is nothing but W by G into A into V minus U whole square sin theta cos theta. And just one more thing, if you write here, that is work done per second or power developed by the jet in x direction. So simply you can say work done by the jet in the x direction per unit time per second. If you take, that will be force in x direction, force of the jet in x direction, and velocity of the plate. So here you may get doubt that work done will write force into displacement, but here we are taking work done per unit time. So here you can displacement by time will become velocity. So directly we are writing here velocity of the plate. So force in x direction is Fx and the velocity of the plate is u. And Fx we got here, if you see, W by G into A into V minus U whole square sin square theta, the same thing we have written, and just u is there. And just when you here rearrange the terms here, so the work done per unit time in the x direction by the jet will be W by G into A into U. This comes here u, and V minus U whole square sin square theta. This is in Newton meter per second. So these are the expressions of the flat inclined plate, moving inclined plate. So this is the Fn force in normal to the plate, and this is the force in x direction, force in y direction. This is the expression for work done by the jet in the x direction. For more videos, please subscribe and activate bell symbol, and also please share my videos with your friends. Thanks for watching.